Every 30 seconds, somewhere on Earth, a brand new Tesla rolls off the assembly line. It's fast, precise, and largely run by machines that never sleep. But how can a single factory produce thousands of high-tech electric cars every day with such surgical precision? Today on the How Factory, we're diving inside Tesla's Gigafactories to see how innovation, automation, and engineering come together to build a car every half minute. The journey starts long before any metal is bent or battery is charged. It starts with design and data. Tesla's vehicles are engineered entirely in 3D digital models that link directly to robots on the factory floor. Every bolt, panel, and weld is planned by software so the machines already know what to do before materials arrive. In the Gigafactory, there's no blueprint on paper, just millions of lines of code. Next comes the raw material. Trucks and trains deliver giant rolls of aluminum and steel to the press shop. These rolls feed into massive stamping presses that hit with thousands of tons of force. Each impact shapes a door, roof, or hood panel in less than a second. The noise is deafening, a heartbeat of industrial power. Robots transfer the freshly pressed parts to stacking lines for inspection. Cameras check for even the slightest wrinkle or dent. If the computer finds a flaw, the panel is recycled immediately. Once the body panels are ready, they move to the body shop, the heart of Tesla's automation empire. Rows of orange robot arms from KUKA and Fanuc spark and move in perfect rhythm. Here, humans are few, robots are many. Each arm can weld faster and more precisely than any human ever could. More than 5,000 spot welds hold each car together, and the robots complete them in minutes. Laser measuring systems confirm every joint is within fractions of a millimeter. Any error means instant shutdown for that station until the line is perfect again. Tesla calls this phase the machine that builds the machine, because every arm, sensor, and conveyor works as part of a bigger mechanical organism. The robots move with choreographed grace, like industrial ballet, passing the car body from one to another as if they were dancers in a metal performance. At any moment, hundreds of car frames are moving through different stages simultaneously. That's how Tesla maintains its rhythm. A new car frame emerges roughly every half minute. Next comes the paint shop. This is where raw metal turns into a work of art. Each bare shell enters an enclosed chamber for a chemical bath that cleans and protects the metal. Then automated robots spray layers of primer, base color, and clear coat in climate-controlled rooms. Temperature, humidity, and airflow are monitored second by second. Tiny particle filters ensure no dust ruins the mirror finish. Depending on the color, a Tesla body spends 6 to 10 hours in painting and baking ovens before it gleams like liquid glass. Paint shops are the cleanest areas in the factory, mais precisely the squin. Workers wear anti-static suits and air is recycled through giant filters. After painting, the body moves to the general assembly area. This is where technology meets craftsmanship. Robots still assist, but humans take over for precision tasks. Workers install the wiring harness, the nervous system of the car, carefully threading hundreds of meters of cable through tunnels and panels. Every plug snaps into place with a distinct click. Touchscreens, sensors, and cameras are connected next. Quality inspectors double-check each connection because one loose wire could disable a feature like autopilot. Then come the interiors. Seats, dashboards, and carpets arrive on their own sub-assembly lines and slide into the main chassis with robotic precision. Tesla designs most components in-house, so each piece fits perfectly without extra adjustment. Modular construction means a Model Y and a Model 3 share many parts, cutting build time and costs. Even the screws are tracked by software to ensure none are missed. If one fails a torque test, the car is flagged for review immediately. Beneath the floor, the heart of every Tesla awaits, the battery pack. Gigafactories don't just assemble cars, they build batteries too. In vast clean rooms, thousands of battery cells are arranged into modules and then into packs. Robots apply coolant, insulation, and seals with microscopic accuracy. Each battery pack is tested for voltage and thermal stability before it ever touches a car. Once approved, Robot cranes lift the entire pack into the vehicle chassis from below, a single operation that takes less than 2 minutes. Now the car is coming alive. Suspension and drive units are bolted on. Electric motors slide into place with robotic arms. The undercarriage is sealed and cables are connected to the battery and motor controllers. Software technicians begin programming the vehicle even before it leaves the line. Each Tesla gets its own digital profile, VIN number, and firmware installed automatically. That's when the screen lights up for the first time, the car's first heartbeat. Next comes testing. Every vehicle undergoes hundreds of automated checks. Cameras scan panel gaps and paint surfaces for imperfections. Ultrasonic sensors listen for air leaks. Machines simulate braking and steering before the wheels even touch pavement. If any system fails, the car is pulled for manual inspection. Only after passing everything does it reach the roll test, where each Tesla drives on a rolling dyno to check motor performance and noise. In the final stage, water jets blast the car to verify weather seals and wipers. No vehicle leaves without perfection. Outside the final checkpoint, rows of fresh cars shine under sunlight. Each was built in less time than a coffee break. Forklifts move them to charging bays where software updates are loaded over Wi-Fi. Technicians perform a last digital inspection before shipping. From here, cars travel by train or truck to delivery centers around the world. By the time a customer takes delivery, the entire journey, from raw metal to drivable EV, has taken just a few days. As the finished cars charge and wait for shipment, Tesla's network of Gigafactories keeps humming day and night. Every process is timed, measured, and analyzed by thousands of sensors. Data flows constantly from the factory floor to Tesla's central servers, where algorithms track efficiency, energy use, and even how individual robots behave. Nothing inside a Gigafactory happens by chance. It's a living ecosystem of machines guided by artificial intelligence and real-time feedback. Inside the control rooms, massive dashboards glow with live statistics. Number of cars built, energy consumed, parts used, and defects detected. Engineers can pinpoint a single bolt on a specific vehicle anywhere on the line. If a robot's movement slows by even a fraction of a second, the system flags it instantly. This is what Elon Musk means when he calls the Gigafactory the machine that builds the machine. It's not just about cars, it's about a self-improving organism that learns as it produces. To sustain that rhythm, Tesla relies on scale and vertical integration. Traditional car makers buy most components from suppliers. Tesla manufactures many of its own: batteries, seats, electronics, even charging ports. By keeping production in-house, the company reduces shipping delays and quality issues. Each factory functions like a small city. Raw materials arrive at one end, and finished cars drive out the other. In Shanghai, Berlin, and Austin, that flow happens almost without interruption, with deliveries leaving 24 hours a day. Automation doesn't mean humans disappear. Skilled technicians, software engineers, and quality specialists still fill every corner of the plant. People handle the tasks that require sensitivity and judgment, aligning trim, verifying welds, troubleshooting errors. They're backed by robots that handle the repetitive, dangerous, or ultra-precise jobs. Together, they form a hybrid workforce that blends human intelligence with machine consistency. Tesla's goal isn't full automation. It's perfect collaboration. Energy efficiency drives every decision. Gigafactories are powered largely by renewable sources: solar arrays on rooftops, wind contracts, and battery storage built from Tesla's own power packs. Waste heat from furnaces is captured to warm other sections of the plant. Excess electricity charges internal fleets of electric forklifts and logistics vehicles. Even the air handling systems recycle filtered air to minimize loss. The idea is to create a closed-loop factory where nothing is wasted, not even the energy that powers production. Scrap metal and rejected panels don't go to landfills. They're melted down and re-rolled within the same facility, ready for another round of stamping. Paint overspray is captured and filtered. Water from cleaning tunnels is purified and reused. In Tesla's ecosystem, every process feeds another. The factory becomes a loop of material, motion, and power that never truly stops. In the battery lines, the scale is even more astonishing. Thousands of small cylindrical cells zip along conveyors at blinding speed. Machines weld, glue, and test them with almost zero human touch. The tolerances are microscopic. Fractions of a millimeter separate success from failure. Finished modules feed into robotic arms that assemble full packs destined for cars or energy storage systems. A single Gigafactory can produce enough cells for hundreds of thousands of vehicles each year. Each completed car is more than a machine of metal and wires. It's also a computer on wheels. Before shipping, technicians load the latest firmware, calibrate cameras, and activate sensors. The vehicle wakes up for the first time. Screens glow, motors hum softly, and software begins its self-tests. Tesla's operating system is what sets it apart. Unlike traditional automakers who freeze software at the factory, Tesla treats cars like smartphones. Over-the-air updates keep improving performance, safety, and features long after purchase. In the testing zone, engineers drive finished cars through short obstacle courses to verify handling and braking. Others run virtual diagnostics, checking every subsystem remotely. The process is ruthless. Even minor issues trigger re-inspection. When a car passes, it's wrapped for shipping, its battery charged to about 50% for optimal transport, and its destination tag affixed. Trucks and trains haul thousands each week to ports and distribution centers worldwide. In some regions, cars are loaded directly onto electric haulers powered by the same technology they carry. Step back for a moment and imagine the full scale. Thousands of parts, hundreds of robots, and miles of conveyor belts, all synchronized so precisely that a new Tesla body rolls out every 30 seconds. The coordination is staggering. At peak output, a single Gigafactory can produce nearly 1 million vehicles a year. To keep that momentum, software constantly adjusts pacing, ordering parts just in time, and rerouting flow when sensors detect bottlenecks. It's the manufacturing equivalent of a living nervous system. Training this system took years of trial and error. Early Tesla factories were chaotic. Robots collided, sensors misread signals, and production halted unexpectedly. Musk famously slept on the factory floor during the Model 3 ramp-up to find and fix problems firsthand. Out of those painful lessons came better design, modular stations, smarter sensors, and standardized parts. The result is today's rhythm, fast, repeatable, and scalable worldwide. Each new Gigafactory learns from the last. Berlin adopted cleaner paint systems and faster stamping presses. Texas introduced the Giga press, one of the largest casting machines on Earth, which can mold huge sections of a car's frame in a single shot. That innovation replaced dozens of welded parts, cutting weight and complexity. Watching molten aluminum pour into a Giga press mold is like witnessing modern alchemy. Liquid metal transforming into structure in seconds. The Giga press symbolizes Tesla's obsession with simplification. Fewer parts mean fewer robots, less assembly time, and greater strength. Combined with new 4,680 battery cells, which double energy density, these changes will define Tesla's next generation. Each improvement ripples through the entire ecosystem, making cars cheaper to build, lighter to drive, and faster to produce. Beyond efficiency, the factories are expanding into new frontiers. Future lines will assemble Cybertrucks and semi-trucks, vehicles demanding entirely new techniques for stainless steel exoskeletons and heavy-duty components. Tesla's engineers are already building specialized presses and robots to handle them. The same AI systems that once optimized sedan production are being retrained to manage these new designs. Adaptability is the ultimate advantage. Inside every Gigafactory, there's also a quiet revolution in data. Machine learning models predict wear on equipment, analyze supply chain risks, and even forecast weather patterns that could affect deliveries. By anticipating problems before they occur, Tesla keeps the line running while competitors scramble to react. It's predictive manufacturing on a scale the automotive world has never seen. The pace of production isn't just about speed, it's about philosophy. Traditional car companies separate design, production, and software into silos. Tesla merges them into one continuous feedback loop. When a design tweak improves assembly time by half a second, it's implemented instantly. Updates flow from digital models to robots within hours, not months. The result? A company that iterates as fast as its code can compile. And the effect shows. Each Tesla that leaves the line represents the future of manufacturing, efficient, connected, and constantly evolving. From raw aluminum to a self-driving electric car in just a few days, Tesla's factories redefine what's possible. They're not just building vehicles, they're rewriting the playbook for global industry. Walk through the final delivery lot, and you'll see rows of gleaming cars lined up like a metallic army. Each one charged, tested, and waiting for transport. In a few days, they'll be on highways across the world, silently accelerating toward the future. Every 30 seconds, another joins them, built by the most advanced production system on the planet. So the next time you see a Tesla glide past, remember the choreography behind it. The molten metal, the roaring presses, the tireless robots, and the people guiding them all. Every detail, every spark, every second contributes to that one incredible statistic: a brand new car every half minute. That's not just manufacturing, that's the rhythm of innovation. And that's how Tesla builds a car every 30 seconds. Thanks for watching The How Factory, where we uncover how the world really works. Don't forget to like, subscribe, and stay tuned for more stories from the heart of human ingenuity.